So hi everyone. Today we will be working on another machine learning project, which is iris flower classification, and the dataset which we'll be working on is iris flower dataset, as you can see on the screen. So this is a very famous or beginner friendly project on machine learning. Basically, when someone start doing machine learning, and like us, when someone do small internship like OSS, Infobytes and all that. So this data set usually people work on. So I've also done this project in like around 2022, 2022, like 3-4 year back, in an internship, and I worked with this data set. And in this project, like from the previous project, I've got some output that you want me to explain, yeah, elaborate, make it more beginner friendly. So in this project I have keeping this in mind, and because of that the video duration can be long, but never mind, you will enjoy every minute of this. And I've also included some of the interview questions which can be asked from you in this from this project. So without any delay, let's start with this project. So let me give you the overview of this project first. So basically this is a machine learning project, as we all know. And what we have to do, so we have to identify the problem statement in any data set. So we will be giving some of the characteristics of a flower, and we have to predict that which category flower it is. So basically the problem is of classification. We have to classify, we have to identify which of the flower is of which category. So we are predicting species from the possible values of Setosa, Versicolor and Virginia. So as you all know that iris flower is divided into three categories: Setosa, Versicolor and Virginica, and we have to predict that only. So these are categorical, not numerical values. Therefore supervised learning is used, and multicolor class classification. So last time, as we all know, in attrition project we were predicting whether the employee will leave our company or not, yes or no. So it was a binary classification, but in this it is a multi-class classification. Why? Because we are predicting from three values: Setosa, Versicolor and Virginica. So if in one line I have to decide, define this project, so it will be iris flower classification is a supervised machine learning multi-class classification problem where the model predicts the species of an iris flower, Setosa, Versicolor or Virginica, using sepal and petal measurement. So moving forward with this project, I would like to explain you the typical machine learning project flow which we use. Basically there is one flow, the dataset changes always, but we follow always one flow. So let me explain you that flow, then we will again come back to iris flower classification. So I was saying that, let me explain typical ML project flow. So first and foremost is loading dataset, because without dataset machine learning algorithm, as you all know, requires data, and without loading dataset we can't do anything. Second, understanding dataset. I don't think I need to explain this, but you have to like understand the dataset, that what is rows and columns are inside that. Third is EDA. The full form of EDA is exploratory data analysis. Next come data pre-processing, a very important step. Fifth is train test split. And this is the flow which we'll be using in this project. So I'm just giving you the overview of it. 6 is model training. 7th is last but not the least is an evaluation, and then we sometime do hyperparametering, but in this time we won't be doing it in this. And now coming to like explaining you this project. So we have iris flower classification. So what I was saying that iris flower is of three categories: Setosa, Versicolor, and Virginica. I would be using these three terms in this project so much that you will at the end understand like by heart all these terms. Don't worry about that. So in the data set, we have been given 5 columns. Uh, Petal length, petal. So we have been given petal length. First column is this. Then petal width. Then sepal length. Sepal width. And the last one is species. Species. So let's understand what is petal and sepal first. So this is suppose a flower, iris flower. This is petals. And like at the bottom which we have sometime green color covering which like types of leaves which we have is called as sepal. So what we have been given is this petal length and petal width, and this sepal length and its width. And from all this four information, we have to identify which species the flower belong. What were the species? Setosa, Versicolor, Virginica. So the main objective of this project is to identify, like I would be giving you some petal length, petal width, sepal length, sepal width, and you will tell me which species does it the flower belong. Okay, so this is basically the blueprint of the project. And now coming for, I will be explaining like each step this time. I know that you were facing some difficulties in understanding, and it would be more interactive, beginner friendly. You can like download, you can just I will be uploading this project on GitHub also. You can download the Google Colab link and use it is in your CVs, and you can just share with your friends if you like it. Okay, and in every step I will be using this smartboard, so don't worry. So now moving forward, uh, so we will be using Google Colab. Google Colab. Okay, I will take a new notebook. Let me do it again. Google Colab. New notebook I am taking. I would be connecting, and until then I would be writing the name of the project, which is iris flower classification. So first and foremost is our loading data set. And how can we load the data set? I would be again like writing iris flower classification data set and from Kaggle I will download it. So I would just go to download. I can download it in two ways, one from the link and another from as a zip. Uh, okay, I will just show you both the paths. So it is downloaded, and like we would do from the link. Let's do from the link because I will tell you why we are doing from the link. So when you like download from upload it here, we like every time you would be opening this Google Colab, you have to again upload it, the CSV file. So we will be using this link, and both the ways I would be explaining you in my another video. So we have got the path, and now what I will be doing is importing import OS path is equal to, I would be using the path which from where the Kaggle has downloaded in my system, and I would print the directory os dot list dir path. Okay, so it is saved as iris as CSV. Now I would be using pandas. Why we are using pandas? Because pandas library is basically used in reading the data set and like doing the EDA and like it reads, so we will be using the pandas library. So we are being using as pd dot read underscore CSV, and this, and here is our iris dot CSV. Now if I so what I've done so far till now, I've imported from Kaggle. I've like find out where my path was there. So here this CSV was saved, and from here I've like for df made a variable df, and from the pandas library I've saved this inside df. Now let's check the first 5 columns of our data set. So it would be df dot head. So this comes over here. So we have sepal length, sepal width, petal length, petal width, and species. So if sepal length is 5.1, sepal width is 3.5, petal length is 1.4, petal width is 0.2, it would be Setosa. Likewise, all this are there. So now you all tell me. So see, basically it would be an interactive session. So my question is that in the data set, which column is the target variable? Like the value we want to predict. Species. From all these four, we are predicting the species, which is Setosa. From all these four values, we are predicting the species. So our target variable is species. Now we will be coming to EDA, which is explore data analysis. So we have first we will be finding out the shape. So I would write printing the shape over here. So it is 150, like 150 rows are there and 5 columns are there. 5 columns are here and 150 rows are there. So if I just like do not print df dot shape also, then also it will give me the same answer. Or then we will write df dot info. df dot info will tell us all the information, as you can see, and much part of EDA depends over here. Why? Sepal length has 115 non-null values. Sepal width all have non-null values. If there will be a single value, we have to do EDA. But here there are no null values. That's why it is a very beginner friendly project of machine learning. If there would be like null values, we have to like do the mean, median, and next time I will explain, when we will do, I will explain how to do that with EDA, but this time we don't. That's why it is a very beginner friendly project of machine learning. So now I will come to okay, I will just copy paste because you know it would take a large amount of time if I just type every bit of code. So this is telling something important to us. What I have done in the species column, I find out the value counts. So the important thing is all classes have the same number of samples. Therefore, it is a balanced data set. This is very important. Like, so first I will give you an interview question. Suppose the distribution was Setosa, first one was 140 and then 55. Out of 150, first one was 140 and then 55. What would be the problem? The problem would be the model might learn to predict either Setosa most of the time and still achieve high accuracy. This is called class imbalance problem, but here it is equally divided. So it is a balanced data set, which is a very good thing for us. Now we will be separating the features and the targets. So for this, and don't worry, I'm explaining you this. So first, here X will have all the columns except species. X will have sepal length, sepal width, petal length, petal width, but not species. Why? Because we are predicting the species. We have to predict the species out of this 4. So X will be having this and Y will be just species. So like understand, this is the question and this is the answer. So they can't be together. So basically X is a so X will have all the column except species. And what does axis 1 over here means? Axis is equal to 1 over here means drop a column. Now my question is, what if axis was 0 over here? Simple. Then we have to drop a row. Okay. So here we can understand that X is feature and Y is target. Okay. Now again one more interview question, like I've been taking lots of interview question and step by step I am explaining you all this. Not a single code I will write and will not explain you. Each and every code I will explain you. And I will also So why do we separate x and y? So the answer for this is x contains the input variables used for learning patterns, while y contains the output variables that a model must predict. Okay, then comes df dot describe. Now this is a bit new thing for you, and I would be explaining all this to you. So from sepal length, sepal width, petal length, petal width, we will finding out all this. I would just explain you here, and then in notepad I will explaining you all the terminologies. Count is the total number of, like, how in the column, like in sepal length there are 150 count. This is mean, this is standard deviation, this is minimum, this is 25% quartile, this is 50% quartile, this is 75% quartile, and this is maximum. Now I will be explaining you each term over here. So first is mean. So let us take, like, imagine like sepal length has values 5, 6, 7, 8, 9. Just imagine it, because like there it is having decimal and all, but for explaining purpose I would be taking these 5 values. Now mean. What is mean? You must have known, but I would explain you. First is mean. So mean is basically the average. Over here the formula will be sum of number upon total number of elements. So it would be 5 plus 6 plus 7 plus 8 plus 9 by 5, which is 7. So mean represent the average value of a feature. That's why in machine learning we are using mean over here. Next is min. What is min? Min is basically the smallest value in the column. So it is 5 over here. Okay. Now next is maximum. Maximum is the maximum value in the data set. The data set, which is 9 over here. Now comes the main thing, standard deviation. I guess you must have learned in college what is standard deviation it. But I would like explain you is STD or standard deviation. So basically what is standard deviation? It tells us how spread out the values are from the mean. So like I would be taking the example of two data set, 6.8 comma 6.9 comma 7.0 comma 7.1 comma 7.2. Second data set is 1, 4, 7, 10, 13. Both have similar mean. You can check, but data set B is more spread out. Why? Because see the difference between the outliers, and over here see the difference. Here is not much, but here the difference between the outliers is very much. So we have two things over here. Low standard deviation, values are close together, close, which is A. High standard deviation, values are widely spread. which is B. Pardon my handwriting, but I hope you are getting the things which I am saying. So next is quartile. What is quartile? So basically quartile divide the data set into 4 equal parts. Suppose the data values are 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So quartile 1 will be 3. Quartile which is 25%. 25% values are below 3. Next will be quartile 2, which would be below 6, and then will be quartile 3 would be below 75%. So median is median is 5, middle value which is 50%, and 75% is 7. So like I was a bit confused. 3 is 25%, 5 is 50%, 7 is 75%. 25% values are below 3, 50% values are below 5, and 75% values are below 7. So this is a quartile. So this is Q1, this is median, and this is Q3. Okay, so this was quartile. So I think now you got all this, and describe is very important for a ML engineer to understand. That's why I've taken out time and explained you every bit of it. Now comes train, test, split. Sorry guys, I'm little under the weather, but I will try my best to explain you the things. Split. So what we are doing over here, just I am explaining you. So we have like distributed train, test, X test, Y test, Y. So what is this? Now let me explain. Our data set was having values. So from 1, 2, 3, 4 till 150. For X, like petal length, petal width, sepal length, sepal width would be like this. All 4 will be like this. Y would be species, that also from 1, 2, 3 to 150. From 1 to 120, we are training our model. From 120 to 150, we are testing our model. We will test our model. For Y also the same. 1 to 120 we will be training, and then so it is training, this is testing, this is training, this is testing. So 120 variable we will be training, and remaining 30 we will be testing. So what we have done, we will be having petal length, petal or 5 columns. We have divided 4 over here, 1 over here. Out of 4, like from every column we will be taking from 1 to 120 will be training, and the remaining will be testing. So the question is, why do we split? So I've been giving you a hypothetical situation. Imagine a teacher teaches you 100 questions. If the exam contains the same 100 questions, scoring 100 by 100 proves nothing. Every question is what is the capital of India, what is the capital of India, it would be of no use. Different questions would be asked. That's why we will be training on different values and testing on different values. If we wanted, we would have done training also in 150 plus testing also in 150, but we are using different data for training and different for testing within the same data set. Okay, so when we will do the training, our model doesn't know about all this value, so here we can test, we will get some new values, we will test. Same also here, also the model doesn't know, it would become these values, that's why it would become some new. So basically what ratio we take 80% for training, 20% for testing. Over here, out of 150, 120 were for training and 30 we kept for testing. So test size is 0.2. So 20% is for testing and remaining 80% is for training. Random state 42. If we don't use random state, you will be getting the same split every time. That's why we are using a random state over here, and you can keep this 42 values anything, 10, 100, anything. It is just I've kept 42 over here. So now what I will be doing, I will be verifying the split. Now just verify and confirm that is the data split in the same parts which you were thinking. Yes, 120 4 columns, 30 4 columns, 120 and 1 column. If you write 1 over here, it doesn't matter. 121 and 31. This is for x, these two are for x, these two are for y. Okay. Now very important thing, feature scaling. So we are using k nearest neighbors over here. Okay, algorithm. Why k nearest neighbor? Because of it is a classification algorithm. Yes, it is of classification, but because k nearest use the nearest. So let me explain you again. We are using KNN, which stand for k nearest neighbors. So if we take petal length, petal width and species, 1.4 is petal length, 0.2 Setosa. Okay, 1.5, 0.3, it is Setosa. Okay, 4.5, 1.5, it is Versicolor. 5.8, 2.1 is Virginica. I have find out these values from the data set only. So if I give a new flower, petal length is 1.6 and petal width is 0.3. Can you guess which it would be? Nearest flower. Compare over here which values it comes to the nearest, right? 1.5. Compare over here which values come it to the nearest, right? Petal width 0.3. So it would be Setosa. Setosa. You might have got what is k nearest neighbor. It find out the nearest to the value. Nearest to 1.6 is 1.5. Like neighbor is something which is nearest to you. In your house you live with a neighbor, that is which is nearest. So it finds out which the um, closest is to is. So it is Setosa. K means, now coming to what does K means in K nearest neighbors. It is number of neighbors considered. Now let's take the example with k is equal to 3. See, I want you to understand the algorithm. The line code for this algorithm is only of one line, but if you haven't understand what is the algorithm is, it would be of no use. You will just tell the interviewer, I use KNN, he will ask explain KNN, then what will you do? You doesn't know the full form of it, how it works and how it is like finding out in a model, then what's the use of using this algorithm? So that's why I'm explaining you each and every step of the algorithm also. And so if we take like k is equal to 3, so the neighbors would now be, here you can see that Setosa, like k is equal to 3, then that would mean you will be taking 3 nearest, close to 3 values. If it would be k is equal to 5, then nearest of 5 values you will be taking. Okay, and this can so if I write, for example of k is equal to 3, I write k is equal to 3, Setosa and Versicolor. Now voting will be done. How many Setosas are there? 2. Versicolor 1. What does that mean? That prediction would be Setosa is equal to 2. Okay. Next, I would be taking the example for k is equal to 5 now. K is equal to 5. Setosa, Versicolor. What will be the voting? Setosa will be 2, Versicolor would be 3. Out of 5, 2 Setosa are there, 3 Versicolor are there. That means prediction would be Versicolor. So now coming to the back of the algorithm, how this algorithm works. This is very important things and understand it clearly. It works by using finding out the distance. Most commonly Euclidean distance. I hope you must have learned in class 12 Euclidean, Euclidean distance. And the formula, like for 2 points, one point is x1 comma y1, second point is x2 comma y2. What would be the distance of it? x2 minus x1 whole square plus y2 minus y1 whole square. So for iris, we have 4 features. What are they? Petal length, petal width, sepal length, sepal width. So the distance is calculating using 4 dimensions. So every time for this 150, this formula is applied at the back of the KNN, and then you get a result which you will be seeing in, I will be showing in next part. Okay, so this was KNN algorithm. This algorithm is slow learner because it takes time and all that, and it is also called a slow learner algorithm, but here it would work with very fine, and I will show you how. And one more thing, from your side you can just explore different algorithm also if you want, like logistic regression. Don't confuse that logistic regression is coming, so it would be of regression, regression, not classification, but logistic regression is of classification. It is a classification algorithm. Same you can do with random forest. Okay, so these are your if you want you can just do it. So in features, so this was feature scaling. The next is we will train the Canon model. Next is training the Canon model. So what is this? First we are first is we are importing KNN algorithm from sklearn neighbors. So from sklearn neighbors we are importing KNN. Then we are creating the model and training it. The model is we have taken like k is 3 over here, and in x train y train we are fitting it, and then we are making predictions. Okay, now let's check the accuracy. Now let's check the accuracy of this algorithm. Accuracy is 1. That means 100% predictions are correct. That's why you now came to know why I was using k nearest neighbor over here. Okay, so next we would be using a confusion matrix. Do you all know what is confusion matrix is? So confusion matrix tells us exactly where the model is making mistakes. I was asked this in interview also, so you can being also asked if you use this project in your like CV and all. So it tells us exactly where the model is making mistake. Here the accuracy is 100%. That means model is not making mistakes, but still it is a part of the project, and it is a very good practice if you use confusion matrix. So we will be also using confusion matrix over here. I think I have written control X. Yeah. So this is the code for confusion matrix. Okay, and now I will this is the output coming, and I know that you must have not gotten what is here, so I will now explain you how to read the confusion matrix. Okay, so confusion matrix. So basically we have row 2D array, so it would be having rows and columns. Rows tell us actual class and columns tell us predicted class. Okay, that actual which was there and which the model has predicted. This is rows and column. Okay, for I will take the example of like what was coming over here, the output which was coming. So it was something like 10 0 0 0 9 0 0 0 11. So this is the rows and this is the column. These are the columns and these are the rows. So what does it was meaning? 10 Setosas correctly predicted as Setosas. Okay. 9 Versicolor were correctly predicted as Versicolor, and 11 Virginica. I would write Virginica, Versicolor, Setosa were correctly predicted by the model. Okay, so this was it. So we can conclude that there was no mistake. This is the main thing. Okay, so there was no mistake. Now we will be making the classification report. Uh, so there are many terminologies over here, and I guess you are being very confused at what is support, F1 score, recall, precision, and all that. And so classification report is basically the final report which we make of the model. We are coming on the last step of this project. So classification report, I would be explaining all you terms this now. So first of all, I would be starting with support. So support means how many actual samples of this class were present in the test set. Okay, so Setosas were 10, Versicolor were 9, and Virginica was 11. That is, it is saying over here, Setosas were 10, it was 9, and it was 11. So what will be the definition of support? How many actual samples of that class were present in the test set. Okay, so the total would be 30 over here. So, and for, if you remember, for testing we have given 30 samples only, so it is matching with the test size. Okay, now next come predictions. What is predictions? Oh sorry, it is precision. So out of all flowers predicted as Setosas, how many were actually Setosas? So like we wanted to check that it is giving right or not, like if it is saying it is Setosa, it is really Setosas or not. It is saying it is Virginica, it is really Virginica or not. It is saying, if it is saying it is Versicolor, it is really Versicolor or not. This is precision. Okay, so now we will be, so we have so out of it is predicted 12 flowers as Setosas. So like if the actually it would be 10 and 2 were not, so then the precision would be in have come at precision 10 by 12, which is 0.83, but we are getting 1, like 1 as precision, meaning every flower predicted as Setosas was actually Setosa, which is a very good thing. We can also conclude that there were no false positives. This is the main thing. Okay, so this was precision. Now next we will be coming on recall. What does recall means? Out of all actual Setosa flowers, how many did we find? Understand precision and recall, very important, because out from these two only F1 is calculated, and that is the main thing. Okay, so I would be giving, suppose there were 10 actual Setosas and the model currently identify 8, then the recall would have been become 8 by 10, which is 0.8. But here we are getting as 1, means the model, you can make notes if you want for later, found every actual flower of that class. Okay, now F1 score, which is very important in the from the point of interview and for understanding also. F1 score. Okay, F1 combines precision and recall. So if one is high and another is low, the F1 will also be decreasing. That is the main thing. We will be getting, we are getting F1 as 1, which means precision and recall are both perfect. Got it? So as you can see over here, our precision is also 1, recall is also 1, F1 is also 1, which is very good thing. Okay, so this was the project, and here like we have done, find out all the things over here, and I would like tell you more things, like what is accuracy. Accuracy means like we are okay, so accuracy I will tell you. Accuracy is coming as 1.00, means 30 correct predictions divided by 30 total predictions, which is equal to 0.1.0 or 100%. Okay, macro average is not very important, but I would tell you. So every class gets equal importance in it, like score of class 1 plus score of class 2 plus score of class 3 divided by 3. So it is micro average, and weighted average, I would tell you the formula of weighted average also. Weighted average. Weighted average consider support. Formula is class score into number of samples divided by total sample. So here we have done like loading the data set from start. If you see that in this project we have done the loading the data set understanding, EDA basics, then we have done the feature separation, train test split, feature scaling, KNN training, prediction accuracy, confusion matrix, and then classification report we have found out. So this was the project that I was all about this project, and this was from the my side, guys. And if you like have any problem, like you can ask in the comment section, you can like appreciate me, or in the comments, or I will from now on I will also giving you my mail ID. You can like personally ping me if you have any doubt or you want to like discuss anything with me. And this was from my side, and this was basically the iris flower classification which we have done today. And I hope you like this video, and more videos will be coming, so of this machine learning, and later I will be moving on deep learning, generative AI projects, RAG projects also in like in coming days. So like subscribe to my channel and be in touch. So thank you everyone.